Hi everybody, let's look at week 10, algebra, expanding and factoring. Firstly, notice that in these notes we've called it factoring. You'll also hear it referred to as factorising. In fact, that's the word I normally use, but it's the same thing. Factoring, factorising, same thing. Now, the distributive law, which we discussed in week 1, was this law that said A times B plus C in brackets. We could distribute that A. If A is multiplying by all of B plus C, we do an A times a B, plus we do an A times a C. So that was the distributive law we used, and we used it for things like mental arithmetic. This 7 times 24, we considered the 24 to be a 20 plus 4, but still the 7 is multiplying all of the 24, so the 7 is multiplying all of the 20 plus 4. We got 7 20s, which is 140. We got 7 4s, which is 28, so 140 plus 28 was 168. And we also said that the distributive law works over a minus. It doesn't just have to be a plus in the brackets here. It worked just as well we had a minus, and again we looked at like 5 times 49. Instead of doing 5 40s and 5 9s, we could have said, well, 49 is a 50 minus 1. So it's 5 50s, which is a nice 250, minus 5 1s, which is a 5, so it's 245. So there's our distributive law, and that's all expanding and factoring, or factorising, is all about. Now, when using the forward direction shown above, what we were just doing, to remove brackets, that's got expanding. We expand our way out of brackets. Expanding is the act of getting rid of brackets. Factoring or factorising is the act of bringing brackets in. So one goes one way, one goes the other. So now let's look at expanding. When expanding brackets, the number that's outside the brackets multiplies everything inside the brackets, as we said, provided that we've got a plus or minus inside the brackets. So if we're asked to expand this, 3x, outside of 2x plus 5, it's a 3 times the 2x and a 3 times the 5. 3 by 2x, or 3 by 2, that's 6x plus 15, it's expanded. So expansion really is just little multiplications of algebra. We've got to be careful, maybe there's a minus out the front of the brackets, got to make sure that we continue using our rules for multiplying positive and negative numbers. A minus 5 times an x, so remember every number owns a sign to its left. So if it's a minus 5 out the front, it's minus 5 times x, which is minus 5x, and it's a minus 5 times a minus 2. Again, every number owns a sign to its left, so minus 5 times minus 2 must give us plus 10. It's an easy one to miss, so just be very careful. Basically what a negative out the front of the brackets does is changes the sign of everything in the brackets. We used to have inside the brackets a plus number and then a minus number. After multiplying everything by this minus, we've got a minus number and a plus number. Yeah, well, that's what minuses do. Minus plus gives a minus, and minus minus gives a plus. Minus changes the sign of things. So hopefully that's okay. That's a vision of where we've been before. Page down. There may be more than 2 terms inside the brackets. There's 3 terms inside the brackets. A positive 3x squared, a minus 2x, and a plus 7. And all of them are going to get multiplied by this number out the front, or this algebraic term out the front. So the minus 7x squared times a 3x squared, well that's got to be a minus 7 times 3, that's minus 21, and x4 times x2 to the x2. Wow, speaking is hard. X squared times x squared, we know from our indices topic that we just add the powers. X squared times x squared is x to the 4, so the minus 21x to the 4. Minus 7x squared times minus 2x, well the minus 7 times minus 2 is a plus 14. Yep. X squared times x is an x cubed. Minus 7x squared times a plus 7, well it becomes minus 49 and it's still an x squared. Fully expanded. Now the next bit, there's only one example here, but they're all exactly the same. But there may be 2 sets of brackets. Now, there could be more, but we're just going to deal with 2 sets of brackets. There's 2 ways to look at this. One way is the slow way, but I want to start with it anyway. I've got an example here, x minus 2 times an x plus 7. And we can consider that to be, well, here's like just the term that's out the front of this bracketed item here. So I could say, well, it's this term, x minus 2, multiplies by the x, and then the x minus 2 also multiplies the 7. And then I can expand each of these terms. That's an x out the front of x minus 2. It's back to front from what I've had, but it's the same thing. That x multiplies each of them. x times x is x squared, x times minus 2 is minus 2x, and here I've got a 7 out front of x minus 2. 7 times x is plus 7x, 7 times minus 2 is a minus 14. And then you can see there's two like terms in the middle, so I've got myself an x squared minus 2x plus 7x, well 2 backwards and 7 forwards, that's 5 forwards. That's a plus 5x and a minus 14. Now, as I said, that was a slow way to do it, but I just did that the way we did the others. What's the faster way? Well, the faster way is as described here, which I'll write out again. I've got an x minus 2 and an x plus 7. And the way I describe here is you start with the first number and you say, okay, I've got myself an x, it multiplies the other x, so x times x is x squared, and it multiplies the other term, which is a plus 7. And x times plus 7 is plus 7x. So I finish with that x, now I move to this minus 2 bit here. The minus 2 multiplies the x, which is minus 2x, and the minus 2 multiplies the plus 7, which is minus 14. So there's 4 bits. When you've got these two bracketed items, they get 4 bits in the answers. I've got two like terms in the middle again. Plus 7 minus 2, well we've got an x squared plus 5x minus 14. So you can see why I prefer the second method to the first. It's quicker. So that's the way we're going to do all of them. Exactly like we've done here. Let's just do another example, and I'll stick some other numbers in. Like I'll do a 2x minus 3 times 6x minus 5. Okay, well let's do it. Let's start with the first one, the 2x, and multiply it across these two terms. 2x times 6x, well that's 12x squared. 2x times a minus 5, that'll be a minus 10x. Alright, I'm finished with the 2x. Now move to the minus 3. Again, remembering every number I need to assign to its left. So that's why I put the box around the entire minus 3 to say, look, all of this. Minus 3 times a 6x stays a minus 18x. And a minus 3 times a minus 5, well that's got to become plus 15. Again, watch out for minus times minus. And the first term is the only x squared term, the last term is the only number alone term, but I've got a minus 10x and a minus 18x. So if I go back 10 steps and go back 18 steps, I've gone back 28 steps. That's minus 28x. So, yeah, I can expand two sets of brackets. Good. Now, the opposite, factoring or factorization or factorizing, is reverse pressive expanding. Okay, what we're doing is, we're bringing in brackets and we're trying to make the expression smaller, okay, by not repeating the same thing. Like if I've got an x in all of the terms, if I've got 3x squared plus 2x cubed minus 7x, you can see there's an x in each term there. I could factorize that and I could bring an x out the front. Well, if I remove an x from 3x squared, what I'm thinking is, what does x times by to get 3x squared? What will times by 3x? What will times by x to get 2x cubed? Well, that'll be a 2x squared. And what will times by x to become a minus 7x? That'll be a minus 7. I'll jump to what I've said here, which might help explain. What I'm really thinking, I look at 3x squared as a 3xx, a 2x cubed as a 2xxx. And so I can see they've all got an x in there. So if I take an x out the front, I just lose an x and an x and an x. And that just, if I think of it that way, that helps me see that the 2x squared just became an x, the x cubed became an x squared, and the x disappeared because I took it out the front. And you can always expand just to check your answer. If I expand this, x times 3x would be 3x squared, x times 2x squared would be plus 2x cubed, and an x times minus 7 would be a minus 7x. And sure enough, that's exactly what we started with. So we're looking for a common factor, but not just a common factor, the biggest common factor, the highest common factor. We want to take out the front what every term has in common. In the example I just wrote here, the only thing they had in common was x's. There's nothing left. In the brackets, look at these terms, a 3x, a 2x squared, and a minus 7. There's no common factor to all three of them. These two have x in common, but minus 7 doesn't have an x. There's nothing left I can factorise out, nothing in common between these three unlike terms. So let's delete that. Go through this example here, was saying factorise 2x plus 6. Well, that was a pretty nice one. 2x plus 6, you can see, hopefully, what's 2x got in it. Oh, what have I got to press? Pen. That's it. What's 2x and a 6 got in common? Well, 2x is just a 2 times x, and I can think of 6 as a 2 times 3. I can see they've both got 2's in them. So if I've got a 2x plus 6, and I can see that the biggest thing they've got in common is the number 2, I can take a 2 out the front, and then think, well, what is 2 times by to get to 2x? An x. What is 2 times by to get to a plus 6? Well, it's a plus 3. And again, I can expand it. That's 2x plus 6. Absolutely 2x plus 3. 2 outside of x plus 3 in brackets is exactly the same as 2x plus 6. And I brought out the highest common factor. So, let's look at this one down here. We've got ourselves an x squared y cubed plus x cubed y. Again, this is what I said before, the way I picture it. I picture x squared as xx and y cubed as yy. So I can see, basically, I've got 2 x's here and 3 y's here. I've got 3 x's here and only 1 y here. So let's look at each part of the term individually. I've got an x squared here and an x cubed here, so they've both got an x squared. Don't just take out an x. They both have an xx in common. This one's got an xx, this one's got an xxx, but the maximum they both have is an xx, so I can take out an x squared. As for y's, the first term has a y cubed, and the second term only has a y, so I can't take more than one y out of both. I can take out an x squared y. So now if I take an x squared y out of this x squared y cubed, I can see that, well, what would x squared y times by to get to be x squared y cubed? We'd have to get times by y squared. And what would x squared y have to get times by to become an x cubed y? The only difference is an extra x. Yep, there it is. And again, if this notation helps to see, here I was saying take out an x squared y. Well, there's the x squared gone, there's a y. Take out an x squared from y from here would be xy. What am I left with? Y squared plus x, which is exactly what we had. Another factorise. I've got a 4xy plus 6x squared minus 2xz. Let's look at individually each type of letter or number we've got. I've got a 4, a 6 and a minus 2. Well, they've all got 2's in them as a maximum thing in common factor. X squared and x, well, why do I write that bracket there? I don't want that there yet. Can I press that? Yep. So x and x squared and an x, the maximum they've all got in common is an x. A y, there's no y here. I can't take a y out of every term. There's a z here, but I can't take a z out of every term. 2x is the best I can do. Each term here has a 2x in it. So what does 2x have to multiply by to get to be 4xy? Well, 2x times by 2y to get there. 2x times what gives 6x squared? Well, that'll be a 3x. And 2x times what gives a 2xz? Well, that'll be a minus z. While I'm at it, I'm going to change pen colour for a second. If I was more proficient with this program, I would be quicker. Another way to think of it. Here I was saying, what does 2x have to multiply to give 4xy? Another way you can think of, since I'm forming multiplication, what I'm doing is dividing 2x out of each term. It's like I'm doing this to work out what goes inside the brackets. That's what I'm doing. I'm removing a 2x. I'm not subtracting it, I'm dividing it. Because division and multiplication are equal and opposite. So this is another way you can think of. Instead of thinking 2x times what gives 4xy, you could put each term over 2x. What happens with a 4 and a 2? Well, I've got 1, 2 there, and 2 2's there. I've got an x on the bottom, it can go, an x on the top. I've got a 2 on the bottom here, and 3 2's on the top. I've got an x on the bottom, which removes an x from x squared, leaving just x. And here I've got a 2 on the bottom, a 2 on the top, an x on the bottom, an x on the top. What am I left with? A 2y. Damn it. Oh yeah, there it is, I'm looking here. Yep, there's my 2y. I've got a 3x. There it is. And a minus z. There it is. So that was another way I can go about it. In the notes we've said about, 2x times what will give you that. If you like what's in the blue pen, maybe that's another way to go about it. Now we've got one that's pretty large. We've got a 12ab4c squared, 16a cubed b squared. Okay, we've got a few things. But let's look at each thing individually. Between a 12, a 16 and an 8, 8's a common factor for 16 and 8, but 8's not a factor in 12. 8 times a whole number doesn't give 12. But I can see that 4 3's are 12, 4 4's are 16, 4 2's are 8. 4 is the largest number that's a common factor for 12, 16 and 8. I've got an a here, an a cubed and an a. So maximum I can take out an a out of each term. I've got a b4, a b2 and a b2. So b2 is the highest number of b's that they all have. A c squared, no c's here, so I can't take c's out. 4ab squared is the best I can do. Let's, whatever your method is here, 4ab squared has to get times by what to give 12ab4c squared. Well, I'd have to have a 3 to turn the 4 into a 12. And a doesn't need to be multiplied by anything to become that a. A b squared needs another b squared to become b4. And I need a c squared. Okay? Take the 4ab squared out of the middle term. Well, 4 times 4 will give 16. A times what gives a cubed? That's an a squared. B squared times what gives b squared? I don't need anything else. 4 times what gives minus 8? Well, there's my minus 2. That's a bit of an over the top minus. A times what gives a? I don't need anything. B squared times what gives b squared? Don't need anything. And I need that c. So there it is, and again we can expand it and say, well, let's check our answer. That would become 12ab4c squared. Yep. That would become 16a cubed b squared. Yep. That would become minus 8ab squared c. Done. We got it all. Is there any other than that? No. And note, if you don't take out the highest common factor, it's still possible to reach the fully factored form. So what I've done here is deliberately not remove the highest factor. Let's say I just didn't notice it. That what's the highest common factor between a 36 and an 18? Well, it's actually 18. 1 18 is 18, 2 18s is 36. The quickest way to answer this question is to take out an 18 and an A and a B. But say I only notice the 9, the A and the B. Yeah, 9's a common factor. A I can take out of both, and B I can take out of both. If I did that, what would I times 9AB by to get the 36AB? Well, just a 4. What would I times 9AB times to get 18AB squared? Well, I'd need a 2 and a B. And I should stop here and say, look, there's still a common factor there. I did not remove the highest common factor. If you look at we go back to the previous page, then anything we end up in brackets doesn't have a common factor. A 2y, a 3x and a z, or minus z, no common factors. 3b squared c squared, 4a squared minus 2c, no common factors. No common factors between x plus 3, between a y squared plus x. So if you find yourself, you've factorised and you've still got a common factor, it means you could have done more. And of course the common factor here is they've still both got a 2. So I could think that that's a 9ab times, well, if I factorise this, a 2 outside of a 2 plus b, 9ab times 2, well that's 18ab times 2 plus b. Which again, if I'd noticed from the start that they both had an 18, both had an A, and both had a B, I would have been much quicker to say 18ab times what gives 36ab, that's a 2. 18ab times what gives 18ab squared, that's just a b. Here's me finding the highest common factor from the very start, and I get in one go instead of having 2 goes. But even if you had 2 goes, we still got there. So just make sure that whatever you've got in your brackets has no more common factors, and we're done. Okay, enjoy.